Welcome, everyone. My name is Joanna Salinas. I am the Outreach Coordinator with the Waukesha County Green Team. For those of you who are new to us, we are a volunteer-based nonprofit 501c3 located here in Waukesha County. Our goal is to promote environmental sustainability throughout Waukesha County communities through education, collaboration, and local action. So we do that by working with residents, businesses, schools, municipalities, and organizations. So we're excited to gather all of you here this afternoon for this great presentation on understanding your utility bill and benchmarking. This is the first in several webinars that we are doing on energy savings for municipalities, and it's part of our Municipal Guide to Sustainable Planning, which is a tool that we have to assist communities with incorporating actionable elements of sustainability into your ongoing processes. So we are recording today's webinar. So I'm going to ask folks just to keep their cameras off and stay muted because that way you're not recorded. But anytime you have a question, type it right into the chat as you think of them. At the end of the presentation, we'll have some time for those Q&As. So today, super excited to welcome Chris Seitz with Focus on Energy and Caleb Brauneller. I said that wrong. Sorry,
No,
Caleb.
you said it. Yep.
Okay, great. With We Energies, they're going to break down how electric and natural gas bills are structured, how and why electricity prices are going to vary during the day, and discuss facility benchmarking as a way to gauge efficiency to better understand what you're actually paying for. So with that, I am going to turn it over to you, Caleb. Welcome.
Hey, well, thank you. So yeah, my name is Caleb Brauneller, and I am on the We Energies Energy Efficiency Services team, and my role is really to try to help customers save energy and thereby lower their utility bills. And so the agenda for today is going to be kind of, what are your energy questions? I know we kind of said stay muted, but I'm pretty informal. If you want to jump in and ask any questions, I can certainly give a try to answer those right away. And then I'll go through the energy bill, and so just kind of the components of that bill and how they're measured, and then introduce some energy management tools that we have available, and then kind of finally trying to identify energy reduction opportunities for facilities. Okay, so the first slide here is a sample bill, and what I've done here is broken it into the different components of the bill. And so number one at the top here, that's going to be customer service and emergency numbers. So that's right at the top. And then the second piece here is the billing date, the account number, and then the next meter read date. And then number three is going to be the customer name and then the address. And four is going to be the electric component of the bill, and so it's got the dollars on there where it's got the previous balance and then any kind of balance forward, and then that's going to be the new bill. And then number five is the electric service component, and what that has is it has the meter number, it has the pre and post reading to give a total electric usage. And then number six is the specifically the electric part of the financial part of the bill. And then number seven is the gas service. So it's got the service type and then the meter reading. And then number eight is the gas portion of the cost of the bill. Number nine is the account summary. So it has last month's and then it has last year's. So then that way you can do a direct comparison. And then there's a graph that has the consumption and the cost breakout for a year. And then 10 is any kind of important messages that We Energies wants to communicate. And then 11 is just the portion of the bill. If you still pay with a check, then that's the portion that you would include that's got all the relevant information on it. Okay, so then here's the back of the bill. I know it's probably a little bit difficult to read, and I'm not going to go through every single one of these, but the bottom line here is that if there's a piece of the bill um, that is difficult to understand or you want to know more about, then you can just flip the bill over and it has these terms and their definitions right on there. And so that's going to be a great resource to just get some information right away. Okay, so moving on to electric accounts. So there's energy usage, which is the total amount of energy that's consumed. And that's broken into two components, on peak and off peak. On peak is typically going to be 9 a.m. to 9 p.m., and that's going to be the when everybody wants to use electricity, right? Whether they're manufacturing or whether people are doing things for leisure, that's when everyone's awake consuming electricity. So there is a premium that's charged for on peak electricity. Um, the other component is off peak, and that's going to be weekends, nights, anything that's not on peak is off peak, holidays. And typically, off peak is about half the price of is on peak. The next component is demand, and I'll get into a little bit of the difference between actual consumption and demand. But to sum it up, demand is the instantaneous consumption of electricity, and so it's really how hard you're pulling electricity from the grid. And so the harder you pull, the more it costs. So that's something to keep in mind in terms of if you're trying to save money on energy. That's one way. If you maybe you can't reduce your consumption, but if you can spread it out, then you can actually save some money that way. And then the third component, it pretty much is going to affect manufacturing. So it's going to be pretty much for primary accounts is power factor. And in a nutshell, power factor is how many amps you're pulling versus how much you're actually utilizing. And so things like motors put amps back into the grid, and so you're not using all of the energy. And so the if you have lower utilization, then you can get penalized for that as well, because that's power that the utility has to deal with that you're not actually consuming. Okay, so here's a little bit more about peak periods. So on peak, um, as I mentioned, that's when the majority of the customers are using electricity, and that's why it's charged a premium rate. It's pretty much going to be 9 a.m. to 9 p.m. unless it's a primary account. Primaries can choose 10 a.m. to 10 p.m. or 8 a.m. to 8 p.m. And off peak is any other time other than on peak. And so you can see the breakdown. It's about 35-65 in terms of the time that's on peak and off peak. So an analogy to energy consumed versus demand is energy consumed. That's the distance. If you were driving in a car, that's the total distance that you would be driving. And energy demand is going to be pretty much how fast you're driving, right? So at the end, you're going to drive the same amount of miles. It's just going to be how long did it take you to get there, right? So if you're pulling a bunch of energy all at once, you do have to pay for that. Okay, here's kind of a cartoon example of a typical building energy use profile. You can see kind of there's the at night when the building isn't occupied, there's sort of this baseline load that happens. And then when people start coming in, turning on lights, starting to use equipment, the the demand starts to go up and thereby the consumption. And then um, by the end of the day, towards the middle of the day, end of the day, there's the peak demand, and that's really what's measured for the day, right? And that's the highest point of consumption, instantaneous consumption, if you will, that's hit, and then that's what ends up going on the bill.
Yeah, I just a comment, Caleb. So
Yeah,
this seems like a perfect example of what a school, that has lunch or provides lunch, and it does, So office buildings too, probably, obviously, as the day gets hotter, right? Early afternoon, more people, more bodies producing BTU, et cetera, et cetera. But yeah, I see this really a lot, this format a lot for schools as they, turn like heating equipment, cooling equipment rather, heating for food, cooking for food, cleaning for food, all that fun stuff. So yeah, it's a good one.
yeah, excellent point, Chris. Okay, so demand charges, there's really, for we energies, there's two types of demands. There's the on-peak demand charge. We can think of that really as a monthly demand charge, right? It's the highest amount of energy that's pulled over the course of the month. And so that's really only applicable during on-peak times. So anything from 9 a.m. to 9 p.m. Is included in that. And the way that we energies bills is in 15-minute increments. So whatever happens between the 15 minutes is kind of irrelevant. It's just the total um, that happens during that 15 minute. The second is a customer demand charge, and that is the highest 15-minute over the last 12 months. And so that's any time, on peak, off peak, holidays, whatever. So you can see here that uh, the customer demand is much less expensive. The problem is that it sticks around for 12 months once you hit it. Um, the on peak demand is much more expensive, but if you hit it 1 month, probably not a big deal because it resets at the end of the month. What I have at the bottom is just sort of an example. This is a screenshot of a bill, just so you can get an idea of the cost of that. All right. So then there are, over the course of the year, there can be fuel cost adjustments and credits. So We Energies pays a market rate for electricity. We Energies does produce a substantial portion of electricity, but then, um, like any other commodity, it's bought and sold on the grid market, right? And so when We Energies needs more power than what they are able to produce independently, then they'll purchase it off the grid. And so the rate structure is based on what that prediction is going to be, the market prediction. So what can happen is maybe the market is ends up being more expensive than We Energies as predicted. At that point, there's a fuel cost adjustment. They have to compensate for what they have had to pay for market rate for electricity. But then, if it ends up being not as expensive as predicted, then you can get a fuel cost adjustment. And so, this can happen for all sorts of reasons, but it's a way to true up at the end of the month what the actual cost is supposed to be. Some examples are, say a power plant gets decommissioned or sold. Um, maybe renewables. There's extra production over the course of the month, right? It's sunnier than they thought it was going to be. Maybe there's a base rate uh, change. All right. So any questions so far? Anybody has? All right. Hearing none, I'm going to go ahead and go into an example. Okay. So this is an example of 24 months of um, energy usage. So you can see that the on peak is the blue at the bottom. So that's the premium, if you will, electricity, and then there's the off peak. And so you can see that the amount of energy consumed ebbs and flows over the course of the year. I've got heating degree days on here and cooling degree days, and you can kind of see that the demand for electricity goes up with the heating degree days. That's of course due to air conditioning loads. It gets hotter, so we increase our demand because we want to be cool. We're pumping that heat outside. But kind of a smaller spike happens in the winter time, right? We use more electricity in the winter. We're either heating with electricity or we're turning on distribution equipment for heating. And so you can see that um, electrical consumption actually does go up um, as well. And here it is an example of demand over the course of the month. And you can kind of see it does follow that same pattern too, where you've got cooling degree days that increase, your demand is going to increase proportionally. Not There's not a lot you can do about that because we really want to be comfortable. Um, but this is just kind of showing an example of kind of a typical ebb and flow of an electricity bill over the course of um, several months. You can see the customer demand piece at the top. Over time, you can see it's starting to go down. Here it pops back up just a little bit, but then it over time, this particular customer is lowering their customer demand. Here's another demand example. This one, the customer demand is saying almost perfectly static, but you can see it, it does follow the cooling degree days pretty well. You've got your base load, kind of in the winter, and then in the summer, it pops just a little bit.
Do you know what kind of customer that is, Caleb?
This is probably going to be kind of like like a typical office building.
Okay.
It's probably not manufacturing because manufacturing is a little more static over the course of the year. It could be, they're using too much to be a household.
Hmm. Yeah, it's a good amount. Yeah.
Uh, and it's probably not a school either because what I would expect is, the dead middle of summer, it would probably taper off depending on the usage of the school as well, right? I
Hmm.
mean, schools are these days going to use air conditioning pretty much all season. But there's probably not going to be as much activity, during the later parts of the summer. Here's a demand example of a customer that primarily uses electricity for cooling. You can see the load really tapers off during the winter, but then when it starts getting warmer again, it really um, uh, peaks in terms of their electrical usage. What's interesting about this one is there was really more cooling degree days, in 2016 than in 2017. And so something happened, whether it was maintenance or whatever, there was less cooling degree days, but they were actually using more energy. And so I thought this was interesting. All right, so then the question comes up, how does a customer know if they're on the best rate? So um, general secondary customer, electrical usage determines the rate, right? So if you go over the threshold where um, your primary or secondary, your billing automatically adjusts. If you happen to be a primary customer, a very large user, then We Energies does an analysis and they'll send a letter to customers comparing the costs of secondary versus primary. So, what's the difference between primary and secondary? Well, primary customers typically are owning their switchgear and substations. And so, um, you do get a break on the actual commodity of electricity that way. But the flip side of that is that primary customers are responsible for maintaining their substations and other types of equipment. So, right, they're not without their maintenance. Transformers need um, maintenance here and there, and checking over to make sure nothing's going to fail. And so, secondary customers, uh, it's a package deal. The distribution equipment is covered under the rate, and so you're paying a little bit more in general, but then you can sleep at night not having to worry about any of the, if anything fails, then the power company will just take care of the material and labor there on that. All right, so we can switch gears a little bit here and talk about natural gas. So natural gas is measured in units of 100 cubic feet. You'll be able to see that on the bill, but then it gets converted to therms, and that's for billing purposes. And then there is a distribution charge, and so the distribution is um, the cost of delivering the actual commodity to the facility. Uh, So there's two different types of We Energies customer. There's a firm gas, and what that is that's the commodity and the distribution are both paid directly to We Energies, right? So We Energies doesn't have very much production infrastructure, if hardly any at all, and so natural gas gets purchased off of the grid, and so um, We Energies buys the gas, and then they resell the gas. And then the other type is transportation gas. And so what that is there's third party gas marketers, and what they do is they'll buy a bulk quantity of gas, and then they'll resell it directly to customers. And so in that case, uh, We Energies customers are just paying the transport costs to get the gas to the facility. They're actually paying the broker for their gas. Um, and so this oftentimes a commodity um, gas marketer will be able to undercut We Energies at certain points of the year. Sometimes, you may pay more, and so it's a little bit um, risky in terms of will it pay back to go with a third party. Typically, if you're a high volume gas purchaser, that's when it works out a little bit better to be a transport gas customer. And so there's really an option. I did some analysis for a school about a year ago, and it turns out they were a transport gas customer, and it ended up being less expensive to buy the gas directly from We Energies. And so we were able to figure that out and get them on a better rate. So, and again, how does the customer know if they're getting the best rate?
Oh, hey, Caleb,
Yeah.
I think there was a question, I think.
Oh, sure. That's in the chat.
Yeah.
All right, let me see if I can see that.
And I can read them because sometimes it's hard to see the chat when you're presenting. So one of the questions was, so who does Wisconsin get gas from? Because you had mentioned that we don't really produce much, right?
Yep. Yep. We do import from Canada, but I would say the overwhelming majority comes from the Gulf of Mexico. We're basically shipping it up north here through the gas distribution networks. Um, we the United States is able to produce so much natural gas that we are an exporter of natural gas. Really, the I'm trying to say here, our constraint is really the distribution, right? I mean, eh, natural gas is pretty inexpensive because there's been all of the fracking and other ways to produce it. And so that's why We Energies has storage facilities. So We Energies buys gas typically in the summer when the rates are less expensive to kind of pass that savings along to the consumer. And then they store it so that when the demand is high in the winter, there's enough capacity to accommodate that.
Okay.
And then the second question is, can only businesses buy transport gas? Um, I'm not sure if a residential customer could buy the transport gas. I really don't think it would work out financially. I mean, it would you would need to buy a lot of gas. I think, if you're eh, uh, the US Bank building in downtown Milwaukee, right? And you're buying enough gas to heat that big building, then you purchase it in bulk, and then it may make financial sense to do that. I think you'd lose money if you were just a residential customer trying to buy it third party. Maybe you could do it, but if it costs more, I'm not sure why you would. That I don't know where the break even point is, but you have to be burning a lot of gas in order to benefit from that.
Sure.
So I don't know if that answers that question, but if you've um, it would be worth probably looking into and talking to a gas marketer if you're using a lot of gas. I'm talking probably if you have a gas utility, and it's $100,000 a month, then it's like, okay, well, then it makes sense to maybe like explore that option. But I think anything less than that, I wouldn't really bother with.
Gotcha. Okay.
Um, and just as kind of a side note, um, okay, so yeah, so We Energies does um, review the gas rates and lets the customer know if they would get a better rate. And there's a lot of times where it's kind of break even. It doesn't really matter if you're third party or if you're buy the gas directly from We Energies. Um, you could break even. There's a big window there, um, but there is We Energies does an analysis if you're a third party, just to say, hey, by the way, you may want to try going with We Energies again because you could probably benefit from doing that. So there's actually two different gas utilities within We Energies operations. So there's Wisconsin Electric and Gas, and there's Wisconsin Gas LLC. All right, so moving on to energy management tools. There is a tool. It's called My Meter, and that's available for all commercial customers, and it's free to sign up. We Energies does want you to know what you're using, and how much you're using, and when you're using it. And so, this information is pretty powerful in terms of being able to kind of um, troubleshoot. If you're trying to figure out why your bill is so high, the first step really is, okay, when are you using it, right? If you're using it at midnight and there's nobody in the building, okay, maybe there's a problem. Um, so this is an example. So right now, My Meter only handles electricity. So we want to get gas on there eventually. It's a work in progress. Um, but this is an example of a screenshot. So you can see at the bottom, here's kind of the window of time. And this is broken out into days. And then I've got my mouse highlighted on one day. And so you can really kind of break it down. You can see that this particular customer is well aware of their on peak. And so you can see they're really dropping their use during on peak times just to try and mitigate that consumption. And so they're able to leverage that and say, okay, we're going to use electricity during off peak and then coast through the on peak times. And here's another screenshot. And I know these numbers are kind of hard to read. The main thing is the fact of that you can really break it down. This is broken down by hour, right? And so this is a couple of weeks worth of hours. And so over the course of the day, you can look and you can say, okay, when's a facility using energy? How much are they using? And then what's kind of the scale here? And you can see in this particular customer's case, they're really dialing back on that on peak time. This is the same customer they showed you before. And then they're using at night. And you can even break it down into 15 minutes because that's how We Energy's bills is in 15-minute periods. So that way you can see, you can get as much resolution as you want, basically. This isn't exactly real time, but you should be able to, it's probably like a 6 to 8 hour lag time on that. So you can really get next days pretty easily with this system. All right, so this is really where my role is. So identifying energy reduction opportunities. We do offer energy assessments. And so what that includes is coming out to the facility, making physical observations as to how the systems are running, what kind of equipment is in place, how they're being operated. And then what I do is I make a report and then provide that report with estimated payback periods for doing these kinds of projects. And then one of the recommendations may be to, I do have a question. Are the energy analysis only available to business and commercial customers? So by analysis, with my meter, it is only available to businesses and commercial customers unless you are unless you have a solar PV system, then you have access to this as well. I think that eventually all of the customers will have access to this. As of right now, all of the commercial customers should be online. So there may be a few other residential customers on there. You can try and sign up with your account number and just see if you can see it. Um, but in terms of assessments, that's not available to right now residential customers. It is only available to commercial customers. But one of the recommendations during an assessment may be to do data logging. And so we do have access to data logging equipment. What we can do is connect up to a piece of equipment or a portion of the building to kind of take a better look at the energy that portion or piece of equipment is using, and then we'll make recommendations on how to operate the equipment, or at least be able to kind of quantify what that equipment or portion of the building is using. And oftentimes that information is useful for making informed decisions. All right, so that's all I have. Does anybody have any questions before I turn it over to Chris? Any more questions? And good questions, by the way. It's good stuff. I'm glad to have feedback.
Yeah, I guess I have a question or two about the My Meter. Is so for a municipality who has multiple buildings and probably multiple meters. So I guess I'm not familiar with My Meter. Is there a way to sync all of those in on one kind of snapshot, or are you looking at facility by facility?
Yeah, good question. So it's based on count numbers, right? And so depending on how you're set up, you could have multiple meters on one account number. And so if you're on one account, you can overlay multiple meters.
Okay.
But if you're a facility that has multiple accounts, you're going to have, I don't believe there's any way to combine accounts. You'd have to just look at each account separately.
Okay.
And so, Yeah, it's maybe not perfect, but at least you can um, kind of look at it on an account level. Um, for me, I like having more resolution. As far as I'm concerned, more resolution is better for um, seeing, really digging into what's going on. If the way I figured is you can always aggregate it later, right? If um, you can download your data with this system, and so you can download a spreadsheet, and then you could always combine everything together with the spreadsheet, right? So if you said,
Uh,
okay, I'm going to download the last 6 months and see what's going on,
mm,
then you can just aggregate it then, on your own, and
uh,
that way you can sort of slice and dice and analyze it however you need to.
Perfect.
All right, thanks again. Good question. All right, if there's nothing else for me, I'm going to go ahead and turn over to Chris.
All right, I think we're ready. Okay. So my name is Chris Seitz. I'm an energy advisor with Focus on Energy. We're a state entity that provides consulting. So we do energy assessments, kind of like Caleb. In fact, we did one together not too long ago. We provide rebates for energy efficient equipment. And then there are also different incentive programs for non-capital equipment projects. So just trying to reduce energy use in your building without, adding new heating equipment or cooling equipment or ventilation or anything like that. So there are ways basically to receive rebates, incentive dollars, essentially just for trying to reduce energy use in your building. So now that I guess we understand, or hopefully understand electric and natural gas bills, the question becomes, how do we know if the amount of money that we're paying is a good amount? Is it too much? Is it too little? What do we think? So one excellent way to try and determine that and figure out if that number is appropriate is benchmarking. So essentially what we're going to do is we're going to take that electric kilowatt hour data and that therm data that Caleb talked about. We're going to take that, convert that into BTU, in this case, kilo BTUs, and then divide that by the square foot of a building. So essentially what that allows us to do is compare different size buildings because the data, the energy use is per square foot. So we have an office building that's 5,000 square feet and a building that's 8,000 square feet. Now we can basically compare those two buildings, if we know that information. Typically, benchmarking allows you to heating. I guess the summer days when it's super hot, the environment, the cooling days. So like he talked about degree days, essentially heating degree days, cooling degree days. So that information can be taken into account when we're benchmarking. So then different parts of the country can also be, for example, we could compare an office building in Wisconsin to a building in Florida or Texas or California. Um, and what that does too, so then if an entity or someone owns multiple buildings, let's say there's multiple commercial buildings or government buildings or school buildings, what have you, and let's say you benchmark each one of those, now you're able to see, how efficiently each one of those buildings is using energy. And if you want to reduce energy use, maybe you go to that one that isn't scoring as well. What's the one that's using more energy than its peers, essentially? Um, and so I think it highlights ways to look at and ways to, it gives you basically next steps, a direction to go, for energy use. So in 2018, Focus and Energy benchmarked 1,200 school buildings. And this scatter graph here is so what you see on the x-axis there is occupancy year, all the way up to 2018 or close to it anyway. And then on the y-axis, you'll see the kBTU per square foot or the energy use per square foot of each building. Now, the reason I like to, I guess, present this slide, this graph here, is that it doesn't matter how new or old a building is. A building can be very inefficient when using energy and also very, efficient when using energy. So if you look in the top upper right-hand corner, for example, there's a dot way up there, probably from a building maybe built in 2010 or so. Very inefficient in using energy, even though it probably has all the latest HVAC controls. There's probably an automated control system, et cetera, et cetera. not doing it right. But then you also see, like, if you look at that dotted line, a dashed line, you'll see there's buildings years and years ago that are also very efficient at using energy. So it doesn't matter, I guess again, the age or what equipment you have, you can use it, you can use energy efficiently or not. So I guess that's why, again, benchmarking is an excellent way to determine, where are you in that pursuit. So what Focus Energy typically encourages is, so EnergyStar.gov has a portfolio manager website, and that's used for benchmarking. And so basically again, just looking at see benchmark and see how efficiently and how efficient that building is. Now, all buildings can be benchmarked, but not all will receive an Energy Star score. So Energy Star is it's a federal government website, and it's free to use. And you'll see here a list of building types that receive Energy Star scores. So schools, grocery stores, offices, courthouses. There are a number of different buildings that receive that score. And that score is basically ranked from 0 to 100. 100 being obviously ideal, excellent, 0 being not so good. I work with schools and governments, and essentially I've seen schools come in the 30s. I've seen schools come in the 90s. So pretty much all over the base. And again, that gives you an idea of kind of where you are and where in a starting point, essentially. So to benchmark, essentially what you need is property information. So what kind of function is it an office building? Is it a courthouse or a school? What is the address? What year was it built? Essentially the gross floor area or square footage, basically. Property use details, hours, occupancy, computers, the number of people working there, etc. And then we need that kilowatt hour and therm data that Caleb was talking about. So this is probably an excellent way if you don't have it, go on to My Meter and download some of that kilowatt hour and therm data. And then that can be used again to benchmark that building. And here's just kind of an image, I think, of the homepage there, energystars.gov. So basically the way you get started, you just get in there, you create a username and a password, and then kind of start entering data. So for utility data, you can do it just manually. There is a spreadsheet upload option. So if you are able to download a spreadsheet, from We Energies or another utility, you can download that, copy it over to a spreadsheet that you download from Portfolio Manager, and then upload. And I've done it. Actually, it works out pretty well. And it's a good way to kind of mass upload or get a lot of information into that system. And then there are also some utilities that basically will do that data upload for electricity on their own. So I guess if you're not a We Energies customer, or even if you are, I guess check with your utility to see what they are able to do or not do in terms of uploading information to Portfolio Manager. Actually, maybe that's a comment for Caleb. Does We Energies do that, or do they have plans for doing that? Do you know?
They're in the works of being able to connect directly and have like a one button click upload. But I can, I've put together a portfolio manager template spreadsheet where you can just paste the data in from a We Energies download. And so, yeah, it's a few more clicks than just automatically uploading, but yeah, I know that is in the works. It may be working, it may be functional at this moment, but I know that they are working on it.
Okay, gotcha. Thank you. All right. And then essentially once you have that data up, so if you look on the right-hand side, this particular, and I believe this was a school I worked with, this particular building received an Energy Star score of 37, so not so good. But you can see shortly thereafter they were up to a 47. So I think once once that lowest score is observed, now then you can, I guess, think to yourself, hey, maybe we should start looking at our building. What's wrong? What's happening in terms of typically it's HVAC, right? So it's heating, ventilation, and air conditioning are the big energy users, especially now that a lot of buildings have LEDs. So that's probably the number one thing you look at is why, why are we so efficient? Is the ventilation system wrong? I think in this case, to be honest, the VAV system or the basically the variable volume system that provides heating and cooling to that big building, there were some malfunctioning units in there, and once those were taken care of, I think the all energy use went down to pretty dramatically once those improvements were made. And then you'll see too below that you'll see the source EUI, site EUI. So if a building does not receive the Energy Star score, you can still look at your kBTU per square foot. I know Portfolio Manager does have median scores for any building that gets essentially uploaded, even if they don't receive an Energy Star score. So you're still able to get an idea of how efficient your building is using energy just from that, kBTU per square foot number. Typically, we use site EUI. I think if you go on there, there'll be different explanations on different ideas. I think source probably takes into account, the source, the generating, equipment, et cetera, like the utility may have. But typically, essentially, we just use site for most of what we do. If you look on the left-hand side, you'll see basically the electric in blue, natural gas in red. So basically the usage numbers. And again, this probably is a school. I think basically usage goes down pretty low, as during the summertime for natural gas, unless you're dehumidifying, unless you want to make sure you're trying to, do not get super humid air in your building. So in that case, a lot of times there is a little natural gas needed for that process. Or in this case too, if you look at the electric use, it's pretty consistent. Increases maybe a little bit in the summertime, but then kind of goes through for with ventilation and cooling essentially. All right, and questions for that little piece that was done there. Looks like we're good. Excellent. So I guess the next step on this one, I don't know if Joanna, you've talked about this or are going to talk about it, but in the fall, we're going to look at ways to save energy, look at the equipment options, ways to change maybe some HVAC control methods in your buildings or different ways to save energy essentially. So step one in your journey essentially is to benchmark a building, see how efficient you are. And then knowing that, and let's say you're not as efficient as you'd like to be, step two then would be, energy conservation or reducing energy use. And that'll be, I think, talked about in September, if I'm right. All right.
Yes, that is correct. September 15th.
All right. Excellent. Excellent. So thank you everyone for I guess listening to me drone on and any I guess last questions. Otherwise, I think we're probably pretty good.
Yeah. Any last questions for either Chris or Caleb?
Absolutely.
All right. Yeah. Well, with that, thank you all for attending, and we will be in touch soon.
All right. Thank you.
Thanks all. Bye-bye.